AS-Level Circular Measure Exam Preparation Questions Part 4. Let's continue with number 2, and I'm going to do number 3 in this video. Again, I want you to stop. I want to really try it on your own after you watch number 1, and then you can continue and check to see if you are correct. Okay, so let's start with number 2. The diagram shows a sector ABC, which is part of a circle of radius A. So don't forget, the radius is A. Okay. The points D and E lie on AB. Okay, we see that. And AC, respectively. And are such that AD equals AE equals KA, where K is smaller than 1. The line DE divides the sector into 2 regions, which are equal in area. Okay, so for the case where BAC is 1 over 6 pi, so think of your special triangles, radians, find K correct to 4 significant figures. Okay, so we will work in terms of, but at the end we will find that value of K. Okay. So let's start. As I go on, I will highlight still a few things. So first, let's find the area, and I will show you now, of triangle ADE. ADE. So AD, and it's just a triangle. Do you see? So don't forget, let me see, BIC, I have to fill it in. It's 1 over 6 pi. Okay, so I use the sine formula. So it's going to be, let's just move it a little bit to this side. It's going to be a half, and then it's going to be Ka, and on the other side it's also Ka, and then it's sin of 1 over 6 pi. Now, I always like drawing that triangle. And I always draw it long because of the explanation. You don't have to draw it so long. You can just memorize it. It's fine. It's an equilateral triangle. But it's always, because it was 2, but that was 2 and this is 1. There's my 90. And then Pythagoras theorem, this is 2 squared minus 1 squared, so it's square root 3. This was 60, that whole one was 60. But remember, 60 always take pi over 3. And the 31 take pi over 6. That's how I remember it. So, if I'm going to simplify this now, I'm going to say it's a half K squared A squared, but now, what is sin? Sin is opposite over hypotenuse. So, what is that going to be? That is going to be a half. And then a half times a half is a quarter K squared A squared. Okay, that is the area of this blue one. Now, I'm going to work out the area of the sector. Okay, so let's make the sector green. Okay, so the area of sector ABC, and that's going to be, the formula is r squared. I know my formula. So don't forget, now the radius is A. Are you with me? So it's A squared, and theta is still 1 over 6 pi. There's no sin of cos, so you cannot go to these triangles. Are you with me? So it's just 1 over 12 A squared pi. Okay, but now comes to it. They said the line DE divides the sector into 2 regions. It divides the sector into 2 regions which are equal in area. So you can say, but area ADE is equal to this area here, because that line there divides it into two equal parts. So that is equal to area DBCE. So basically, you can also express the area of the sector. So therefore, area of sector ABC can also be expressed in another way by taking the blue, are you with me? I want to make it, so taking the blue, the quarter, okay, let's put it equal. So the quarter, k squared, a squared, and just multiply it with 2. Okay, so basically what I'm trying to do, I'm trying to express the area of the sector into two different ways. Okay, so then I can end up by saying it's going to be a half, okay, after I multiply, so it's going to be a half a squared k squared. Okay, but as I said, that is going to be equal to that. So I'm going to equate it now. So I'm going to say equate, this is what I'm saying here, equate the expressions for the area of sector ABC. I'm just going to stop, and I really just want you to make sure that you follow what I did. So basically, what I did, can I just show you? I worked out this area, but because I know that this area is equal to this one, I basically took this blue area and I multiplied by 2 to get an expression for the area of the sector. Okay, in terms working with the blue one. But then I take the normal formula for the area of a sector and I work out this green one. So now what I'm going to do, I'm going to take the two different, because I know they're equal, and I'm going to put it equal to each other. So I'm going to now take this one, can you see this one? And I'm just going to put it equal to this one to get my value of k. Okay, so I'm just going to say, okay, so let's just fill it in. So it's that 1 over 12, the one that I just worked with the area. And then the blue ones, the two blue ones, which was a half a squared k squared. Okay, and now I'm just going to start dividing. Now let's just go and I just divide with 1 over 12a squared, divide 1 over 12a squared. Do you see why? So the a squares cancel. So if I say, okay now, and I'm sitting on this side just with a pi, because, and on this side 1/2 divide with 1 over 12, it's going to give me 6k squared. And remember I want k. So to get k, I'm just going to say pi over 6, and then I just take the square root. And then I'm just going to press this on my calculator. And therefore, I'm going to get that k is 0.7236. And because they said, let's just see what they said, correct to 4 significant figures. So correct to 4 significant figures. Correct to 4 significant figures. And that's basically what we do there. Okay. I think the best is to do it another time and to just see, because this is very nice. So we are trying to get information from two different angles, and then because we know it's the same information, we just equate it at the end. Okay, let's do the next one, the final one in this video. Okay, I still have a last set of videos, not finished with the videos. I have a very interesting one after this one. Okay, Okay, so let's do number 3. Let's move up. Let's see what they are all showing me. The diagram shows a semicircle. Okay, it's a semicircle with diameter AB, center O, and radius R. The point C lies on the circumference and angle AOC is theta radians. The perimeter of the sector BOC, oh, this is very important. The perimeter of the sector BOC is twice the perimeter of the sector AOC. Find the value of theta correct to two significant figures. Okay, now I'm first going to start. Because I know it's a semicircle, I know that this angle will be pi. That whole one. A straight line is always pi. But if I want to just find this one, let's make it red, then it's pi minus theta. Okay, so let's start. Let's say, I'm saying, and I'm going to do, I will take a red and let's make this one green. Okay, so angle AOB, okay, let's start. Let's start with angle COB. Let's make first angle AOC is theta. And then angle COB is theta minus pi. Okay, are you with me? Now, sector AC, let's begin. Sector, that one, AC equals R theta. Okay, because remember, that is R. There's my radius. Then that is also R. Then I say sector BC, which is that one. So sector BC equals R, and don't forget this is now theta, so pi minus theta. Okay. Now, perimeter, because I want the perimeter, so that comes together. So I say perimeter AOC equals, remember there's two R's, plus that R theta. Just want to get, sorry. Okay, I wanted to move a little bit. So perimeter, I'm going to write it just underneath, otherwise my space. Perimeter BOC is now that red plus that plus that. So that is also going to be 2R plus R pi minus theta. Okay, now we go to this statement. The perimeter of sector BOC is twice the perimeter. So if I take the green one, if I say 2 times perimeter, remember I want to make AOC, that will be equal to perimeter BOC. Remember, it's an equal sign, so we put the 2 on this side because it must balance like a scale, so we put it on the other side. So now I'm just going to say 2 times that green, 2R plus R theta equals the red. So 2R plus R pi minus theta. Okay. Now I'm just going to work it out. Okay, so if I start working it out, and I think now I will just use the same color. So it's going to be 4R plus 2R theta equals 2R plus R theta minus R this. Okay, Now, I'm just going to, so they say theta. So bring the thetas to one side. Do you see there's a theta? So it's 2r theta plus that r theta. So it's always the one that you want to make. Just bring that to one side. So, and then it's 2r plus r pi minus 4r. Okay. And now I'm going to take theta out, and it's 2r plus r. So it was actually like terms. Did you see that? And then this is going to be 2r minus 4r. So it's r theta, r pi, this one, minus 2r. Are you with me? Now, this is going to be 3r theta, and this is now r. I can take out r as a comment, and it's pi minus 2. And then I'm just going to divide by 3r, and I'm going to divide by 3r. So I'm going to get that theta, theta, that cancel, is going to be pi minus 2. It's nice, otherwise I could not do it. Pi minus 2 divide by 3. And then I'm just taking my calculator, and it's always first good to write the full calculator display before you simplify. So shift the real pi, not 3,142, minus 2, divide 3 equals. And that is first the calculator display, 380530884. But don't forget, they said two significant figures. So therefore, theta equals 0,38. And that will be in radians. Beautiful sum. Okay, make sure you can go to, I call this level 3. So make sure you can also reach level 3 in circular measure. We will continue in the next video with also an interesting example. A final note. Most of the videos on this channel feature examples from the Y equals mx+c to success mathematics books. Try your best to purchase your own hard copy from one of the following bookshops. This will enable you to highlight and make personal notes in your own textbook. And remember, the only way to learn mathematics is to do mathematics. Best of luck.